simplified model. In this video, we shall illustrate the simplified model of the computer by analyzing the geometric series summation. The geometric series summation will be special since we shall have three different implementations. The Python code of the first implementation will be trivial, and the straightforward implementation will be the following. Def geometric sum x n. Sum gets 0, I gets 0. While I is less than or equal to n, prod gets 1. J gets 0. While j is less than I, prod gets prod times x. J gets j plus 1. Sum gets sum plus prod. I gets I plus 1. Return sum. Now let's see if we can count. Let us start with line 2 since line 1 is not executable. In line 2, we have fetch and store. That'll give us 2. Line 3, also it's fetch and store. That's also 2 operations. In line 4, we have fetch, fetch, and compare. That's 3. But how many times it is executed? The runtime for line 4 is 3 times n plus 2. Now it's your turn, and you may wish to pause this video and try yourself first, counting the operations from lines 5 to 12, and even more, compute the total runtime. Now let's continue and analyze the runtime of line 5. In line 5, we have 2 quantity n plus 1. Line 6, we have 2 quantity n plus 1. In line 7, we have 2 times the summation of I plus 1, where I is 0 to n. In line 8, we have 4 times summation of I, where I is equal to 0 to n. In line 9, which is the same as in line 8, we have 4 times summation of I, where I is 0 to n. In line 10, we have 4 times quantity n plus 1. Line 11 is the same as line 10, 4 times quantity of n plus 1. And in line 12, we have 2 operations. This will give us a total runtime of 11 over 2 times n squared plus 47 over 2 times n plus 24. Lines 7 through 9 contain the arithmetic summation series. To simplify this, we apply the equation summation of I, where I is equal to 0 to n, is just equal to n times quantity n plus 1 over 2. Again, the simplified model runtime for the geometric series in this implementation is C of n equals to 11 over 2 times n squared plus 47 over 2 times n plus 24. The next video will illustrate the second implementation of the geometric series summation. There, the Horner's rule is applied to eliminate unnecessary multiplications as we have observed in lines 7 through 9. See you there.